Let's look at the new lesson today. It's a 5.5, multiplying and dividing a polynomial by a constant. Before we talk about the multiplying and dividing a polynomial by a constant, let's review what we learned in Math 8. In Math 8, we learned how to multiply a constant by a monomial. For this monomial 3x, we can use 3 yellow rods to represent 3x. Multiply by 2 in front means I have 2 sets of those 3 yellow rods. So I need to get another set. Right now I find that I have 6 yellow rods in total. So 2 times 3x, the answer is 6x. If we want to multiply this constant by this monomial symbolically, we only need to multiply this constant by the coefficient of the monomial 3x. 2 times 3 is 6. And then let's keep the variable x. Let's look at negative 3 times negative 5x. Negative 5x, we know, okay, we have 5 red rods. When I multiply this negative 5x by negative 3, I look at 3 first. This 3 means I have 3 sets of those 5 red rods. So for those 15 red rods, we know this one is negative 15x. But we still have a negative sign in front of 3. So this negative times this negative 15, negative 15 becomes positive 15. Or we can say this negative sign allows me to flip the color of those rods. So I need to change all those 15 red rods to 15 yellow rods. So the answer is 15x. If I want to just multiply this constant by this monomial symbolically, the same as this one, I just multiply this constant by the coefficient of the monomial. The coefficient of this monomial is negative 5. Negative 3 times negative 5 is 15. Then I keep the variable x. This is the reason why I can get 15x. So let's review the second concept that we learned in Math 8. This one is called distributive property. The distributive property is a times brackets b plus c. We can distribute this a into each term in the brackets. So if we remove the brackets by distributing a into each term, it means a times b plus a times c. Let's look at the first example. 4 times brackets n plus 5. I distribute this 4 into each term in the brackets. It becomes 4 times n plus 4 times 5. 4 times n, 4 times 1n, 4 times 1 is 4. So we can get 4n as the first term. 4 times 5, this one is easy, it's 20. Keep the plus sign in the middle. So let's try the second one. Negative 8 times brackets w plus 2. I distribute negative 8 into the brackets for each term. So I will get negative 8 times w plus negative 8 times 2. Negative 8 times w. Negative 8 times 1w times 1. It's negative 8w. Plus negative 8 times 2. Negative 8 times positive 2. Negative times positive is negative. So plus negative 16. Then I can remove the brackets on this negative number. Positive, negative become minus. So the answer is negative 8w minus 16. If you have trouble in changing the signs here, okay, let's do a little bit more practice. Let's look at this one. Using the distributive property, I can get 5 goes with 8. 5 also goes with this one. But in the distributive property, we have the plus sign here. Then we keep the plus sign here as well. So before I distribute 5 into the brackets for each term, I will change 8 minus c to 8 plus negative c. And we all know that when we subtract two integers, we change the minus to the adding and the opposite to the second number. So we opposite c, which becomes negative c. Then I distribute 5 in. So 5 times 8 plus 5 times negative c. 5 times 8 is 40. Plus 5 times negative c means negative 1c. 5 times negative 1, negative 5, and keep the c. Plus, minus, positive, negative become negative. So I can change these two signs to one sign, which is the minus sign in the middle. So later on, if you guys can develop enough proficiency on the distributive property, for some of you guys, I can recommend you guys just keep the minus sign in the middle. You only need to distribute 5 into each term. So you can just do 5 times 8 minus 5 times c, which is 40 minus 5c right away. Okay, let's look at the last example. Negative 4 times brackets negative 5 plus 8. I will do the same thing. This one is the plus sign. This one is exactly the same as the sign in the distributive property. So what I need to do is I can distribute the negative 4 into the brackets right away. So negative 4 times negative 5 plus negative 4 times 8. Negative 4 times negative 5. Negative, negative become positive. Plus negative 4 times 1a. Negative 4 times 1. Negative 4. And keep the a in the multiplication. So we will have 20 for positive and the negative. Let's combine these two signs into one negative sign. So it's 20 minus 4a. Okay, so based on the distributive property and how to multiply a constant by a monomial, right now we can look at how we can multiply a polynomial by a constant. So here we will introduce two methods. The first method is using algebra tiles. Of course, the second method is just like the adding and the subtracting polynomials. This is called symbolic method. Let's look at the first example. 3 times brackets negative 2m plus 4. This time, this one becomes a binomial. It's not a monomial anymore. So what should we do when we multiply a constant binomial? We sketch 3 rows of 2 negative m tiles and 4 positive 1 tiles. What does that one suggest? So I will still model this binomial in the brackets first. Negative 2m plus 4. Negative 2m. This is the first term in the binomial. Negative 2m means I need to drag 2 red row. Positive 4 means I drag yellow little squares. Multiply by 3 in front means I have 3 rows, or you can say 3 sets of those algebra tiles. So what I will do is I copy those algebra tiles in the second row and in the third row as well. So this is the reason why we say we have 3 rows of this binomial. So this one is shown on your guys' lesson note already. So you can look at the note to help you understand this algebra tile method. So right now, let's look at those 3 rows of 2 negative m tiles and 4 positive 1 tiles. The answer is I have negative 6m. And how many little yellow squares are there? So there are 12. So that means I have plus 12. So this is the answer from the algebra tile method. Let's look at how we can solve this one symbolically. If we want to solve this one symbolically, we multiply this constant by each term in the brackets, which is the distributive property. So I use 3 times the first term, negative 2m, and 3 times the second term, 4 in the brackets. 3 times negative 2m. So this is a constant times a monomial. We know we only need to multiply this constant by the coefficient. So we will get negative 6m. 3 times 4. This one is 12. So we can get the same answer as the algebra tile method. Let's look at the second one. Oh, this time, this polynomials becomes a little bit more complex. And this polynomial is also a trinomial. Negative 2 times brackets negative n squared plus 2n minus 1. So what we need to do is, I will use the algebra tiles to model this trinomial first. Negative n squared means I drag 1 big red square. Plus 2n means I need to drag 2 yellow rods. Minus 1, that means I need to drag 1 little red square. So this number negative 2, I do 2 first, and then we will do negative sign later on. So this 2 means I need to get 2 sets, or we can say 2 rows of those algebra tiles. I will still have another 1 big red square, 2 yellow rods, 1 little square. With the negative sign in front, means I need to flip all the tiles to the other color. So this one is similar to multiplying all tiles by negative 1. So all tiles change their signs. Negative becomes positive, vice versa. Means positive become negative. So 2 red big squares become 2 big yellow squares. 4 yellow rods becomes 4 red rods. 2 little squares become 2 little yellow squares. So this time I only need to change the algebra tiles to a polynomial. So this polynomial will be 2 yellow big squares means 2n squared. 4 red rods means minus 4n. 2 little yellow squares means plus 2. So that's the answer we can get from the algebra tile method. Let's look at the second method. How can we multiply this number by this trinomial symbolically? If I want to multiply by symbolically, make sure, okay, I can change this negative sign to the plus sign, and thereby I can use the distributive property. Negative 2 times negative n squared plus 2n, I change negative 1 to plus negative 1. Then I distribute the negative 2 into each term in the brackets. So I will get negative 2 times negative n squared plus negative 2 times 2m plus negative 2 times negative 1. Negative 2 times negative 1n squared. It's negative 2 times negative 1. Like what we introduced in the very first example. When we multiply the constant by a monomial, we only need to multiply this constant by the coefficient of this monomial. So negative 2 times negative 1 become positive 2n squared. Negative 2 times 2, it's negative 4n. So plus negative 4n. Plus negative 2 times negative 1 become positive 2. It's just 2. Then I also can change this positive negative to the one negative sign, minus 4n plus 2. So symbolic method is the same as the algebra time method. We can get the same results. This time, we need to look at an example of dividing a polynomial by a constant. This example is 6x divided by 3. It's a monomial 6x divided by constant 3. Let's use the algebra tiles. 6x means I have 6 yellow rods. Divided by 3, that means I arrange those 6x tiles, those 6 yellow rods, into 3 rows. I divide into 3 rows. So I will find that there are 2 yellow rods in 1 row. So 6x divided by 3 is 2x. Or we can use an area model. 6x is the area of a rectangle. Divided by 3, 3 is the width of the rectangle. Let's just assume this is the width. So the length will be 2x. Because only 2x times 3, we can get 6x. Let's look at another example. All of you guys will feel this one is so easy. 2 sevenths plus 3 sevenths. If they have the same denominator, you guys know how you can add these two fractions up already. You keep the denominator, only add the tops up. Vice versa, in this lesson, we will use this one backwards. If you see a fraction with the adding on the top, I can split this fraction into the sum of 2 fractions, which is 2 sevenths plus 3 sevenths. Let's look at an example 2. Divide a polynomial by a constant. Here are 2 methods. Of course, the first method is still using the algebra tiles. This time the example is 4s squared minus 8 divided by 4. What we need to do is we need to use the algebra tiles to model the polynomial in the numerator. 4s squared means I have 4 big yellow squares. Minus 8, negative 8 means I have 8 little red squares. So those algebra tiles represent the top, 4s squared minus 8. Divided by 4, that means I divide those algebra tiles into 4 sets with the same algebra tiles in each. So divided by 4, I divided the 4 big yellow squares into 4 sets, 1 in each. I divide those 8 little squares into 4 sets. I have 2 little squares in each. So my answer is 1 set, which is s squared minus 2. So let's look at how can we use what we just reviewed in this fraction case to divide a polynomial by a constant symbolically. So what we will do is I change 4s squared to 4s squared plus negative 8 divided by 4. So I write on this quotient as the sum of 2 fractions. So I change this entire fraction into the sum of 2 fractions. It's 4s squared divided by 4. So it's 4 divided by 4. This 4 has s squared. Let's keep it. Then plus negative 8 divided by 4. 4s squared divided by 4. You only need to divide the coefficient of this monomial 4s squared by the number. 4 divided by 4 is 1. So 1s squared plus negative 8 divided by 4, it's negative 2. 1s squared, we have already talked about this one several times. This 1 in front of the variable can become invisible. So you can just write out as a square simply. Plus negative 2. Positive negative you can combine these two signs into a minus sign. So it's x squared minus 2, which is the same as the answer we got from the algebra tiles. Let's look at this one. For this one, I hope you can use the algebra tiles to try yourself. But I only want to introduce the symbolic method. If I want to use the symbolic method, I need to write down the quotient as the sum of 3 fractions. What are those 3 fractions? Let's change all the minus to the adding in the numerator first. So I change this minus 9 to plus negative 9, then divided by negative 3. This time, what I will do is I split those terms on the top into 3 fractions. So it's negative 6x squared divided by negative 3. Let's put on x squared next to negative 6 as well. Then plus 3x divided by negative 3. Then plus negative 9 divided by negative 3. Likewise, we only need to divide the coefficient of negative 6x squared by negative 3. Negative 6 divided by negative 3, 2x squared. Plus 3 divided by negative 3, positive 3 divided by negative 3, it's negative 1x. Negative 9 divided by negative 3 become positive 3. So this time I will have 2x squared, positive, negative, combine these two signs into a negative sign. So minus x, 1 can become invisible. Then plus 3. So this is the answer I can get from the symbolic method. I hope that you guys can try those 4 multiplications or divisions yourself and check the answer with mine later on. So I hope that you guys can pause for a little bit while here, then continue your video. Look at if you can get to the same result as what I got from here. Okay, let's look at this one. The first one. First, I change the minus to adding. So negative 6 times brackets 2w squared plus negative w plus 5. Then I can distribute negative 6 into each term in the brackets. So it's negative 6 times 2w squared plus negative 6 times negative w plus negative 6 times 5. Negative 6 times 2 is negative 12w squared plus negative 6 times negative 1w. Negative 6 times negative 1 plus 6w. Negative 6 times 5 plus negative 30. So the final answer is negative 12w plus 6w minus 30. The second one is dividing. I split the numerator into the sum of 2 fractions. So negative 10 divided by negative 2 plus 4 divided by negative 2, w squared. Negative 10 divided by negative 2 is positive 5. Plus 4 divided by negative 2 is negative 2, w squared. Positive, negative becomes one sign, negative. So the final answer is 5 minus 2w squared. Let's look at C. I will change the numerator negative 6wg minus 16w2 plus negative 16w. This minus 4g I will change to plus negative 4g divided by 2. Then I split the numerator into 3 fractions. So it's negative 6 divided by 2 wg plus negative 16 divided by 2 w plus negative 4 divided by 2 g. Negative 6 divided by 2, negative 3, keep the variables wg. Negative 16 divided by 2, negative 8, keep the variable w. Negative 4 divided by 2, negative 2, keep the variable g. So the final answer is negative 3 wg. Positive negative become minus 8w. Positive negative becomes minus 2g. Okay, this time let's look at the last example. 3m squared minus 7 brackets times negative 4. You will find that this constant is not in front of the binomial. It's behind the binomial instead. If you don't like this way, I will swap this constant with this binomial. I can switch them around and it become negative 4 times 3m squared minus 7. Once you put the constant in front, you can still use the distributive property. The reason why I can switch negative 4 and 3m squared minus 7 around is merely because this is the multiplication. We all know 2 times 3 is the same as 3 times 2. So this reason I can move negative 4 to the front. So after I move negative 4 to the front, I can change 3m squared minus 7 into 3m squared plus negative 7. So then I have negative 4 times 3m squared plus negative 4 times negative 7. Negative 4 times 3 is negative 12m squared plus negative 4 times negative 7. Negative 4 times negative 7, positive 28 plus 28. So here we got all the examples in this new lesson.